Okay, now the class is recording. That's good. We left off at the very end of chapter 2, so we're just going to finish up there real quick. Okay, so,
If it's not too much, Demonte, can you go over oh, there you go, the troubleshooting theory again?
oh yeah, no problem. So, the troubleshooting theory is the most important part of being a PC technician. And it's actually this theory that no matter where you go within IT, you will always use these 6 steps when you're troubleshooting any sort of problem. So, the way we approach this is that of a detective. First thing we would do is identify the problem, and well, I'll go through the steps and then I'll try and list examples of how we work through something. So first we
Okay.
identify the problem. The second would be to establish a theory of probable cause. So what could it be and what could it not be? After we've done that, the third step of the troubleshooting theory is to test it to determine the cause. So once you have the list of things it could possibly be, you want to test until you eliminate and you're down to the last thing. The fourth thing, no, the fourth step after you determine the cause is to establish the plan of action to resolve the issue and implement a solution. After that, we want to verify that the full system is functional, that the solution worked, and then, if need be, we would implement preventative measures so that a certain problem would not reoccur. And with that, documentation is very important, which is our last step to document the findings, the actions, and the outcomes. And this is very important because if a certain problem were to repeat itself, instead of having to, if I won't say that because it's always good to go through the steps, but if there's a document or a knowledge base where this problem has happened before and you can see how someone else corrected it, it makes the troubleshooting process go by much faster. And you will hear this everywhere, but documentation is the most important thing. Where I've been in interviews where I've heard managers complain that their techs don't document any of the work. It's whether it's a small project, a small solution, or a large scale project. And without that documentation, they had to scrap everything and start over. So when you mention that you document everything that you do, it really helps you stand apart from other applicants and other techs that are being looked at. Okay, so wait 1 second. I want to make sure I'm on the right slide. Okay. All right, so when we're identifying the problem, we want to. Oh, I have an echo coming through. Let me check that. All right, is that better? All right, cool. So, identifying the problem, we don't want to be, we don't want to accuse the user, although 90% of computer problems are caused by the user. We never want to blame them for anything. We want to also offer to perform backups of all information. especially since most users don't back up their information. And there will be time, in fact, just recently at my job, we had to restore somebody's machine, and they haven't backed up anything in 2 months. So all of that work was lost. So backing up the information is very important. But when we identify the problem, we want to ask the user about recent changes, anything that they noticed differently, or anything that could have happened recently. A lot of times on Mondays and Tuesdays, lots of users will have issues because Microsoft updates ran over the weekend, and that caused a problem. Um, and with that, we want to ask what happened, anything that they noticed, whether it was different. And then, not even with them, but you sometimes, depending on the issue, want to ask the people around them to see if they're experiencing the same issue or not, to see whether it's a large scale issue versus a small scale issue. And we'll get more into that. All right. So then, establishing the theory of probable cause. What could it be? What could it not be? Given, no, taking what you were given by the user when you asked them what happened and what the problem was, you can then take that to the internet. If there are certain error codes that come up, say it's a Microsoft error or something like that, Microsoft has a knowledge base where if you type in that error code into their base, they will, especially if it's common, they have a solution for it. So that helps save a lot of time. You can follow up what Microsoft documented on how to solve the problem. So research via the internet, ask other technicians, and check in company records. That's that documentation and knowledge base that I spoke about. And then if it's an external issue, for example, you have a user that says their monitor is not working or something like that. You could check to see if there are damaged connectors, if everything's plugged in correctly. I always start from the outside and go in. All right. First, making sure everything is plugged up how it's supposed to be. Then seeing if everything's connected, if the system is running hot, or if you hear anything strange that you should not be hearing. Um, and usually with those, for most of your issues, if you check that, you can solve it. If by checking everything outside, you still haven't come to a solution, then it's an internal issue. All right. And then testing the theory to see you would, how do I want to word this? You would test the theory to see all of your solutions or probable cause, and testing it will help verify that something is broken. Um, I'm trying to remember an incident. It'll come back. But in the event that you test what you think it is and the theory is not confirmed, then you can develop a new theory after that on what the problem might be or could be. Now, once you've identified the problem and you've taken all the action you can, if you still have not reached the solution, this is where you would then escalate the problem. And it's always great to ask for help because some problems you may have never seen before. So there may be a higher level tech with the help desk, depending on the company. Most companies, they have tier 1, tier 2, tier 3. So coming in at the screen door, you'd be a tier 1 technician. If something is out of your reach or you've done everything you could, you would then ask higher up to a tier 2 technician. If they can't get it, then it keeps escalating up to the higher up until the problem is solved. Um, Please
I have a
excuse
quick
my
question.
allergies. Oh yeah, I'm sorry. I'm running through this. Any
No.
questions?
Yeah, quick question on what you're just saying about looking at the components first, like working from the outside and then going in.
Right.
What has been your experience lately? Like, are the components breaking down faster than they used to, or is the lifespan of them still the same?
It's not so much of a lifespan issue. Like when I say look from the outside going in, it's mainly to check like the visual cues and connections. Say if I say if a user says they have no internet connectivity, before I would go call in the network guys at the operations center, I would go up to their computer, check to make sure that their Ethernet cable is plugged in correctly to the computer and then correctly to the wall. And then the next thing I would check for is when you have an Ethernet plugged into your computer, you have on that slot what are called indicator lights. And they'll flash orange and green. So if the lights are lit up, then I know that everything's wired up correctly. If the lights are not on, before I even go inside the computer, what I would do is take another Ethernet cable, because it could be, just by looking at that alone, it could be a bad cable. So I would replace it to see if the indicator lights would come on then. If they do, and there's still no internet connectivity, then I would go into the computer. And when I say into, I mean not open it up, but I would start doing network troubleshooting from the command line on the desktop. And that's another part we'll get to. But some things I can show you with that step is there's a command to test whether, just to test your internet connectivity. So the IP config, which stands for your Internet Protocol Configuration. I would test that command to see if the computer has an IP address, because even if everything is wired up correctly, it may not have been given the IP address to be able to network with other computers or on the network. So this is when I go from external to internal. And then, dependent on what I saw at this step, I would troubleshoot further. But before I did any of this, I would check the connections first, check the outside of the machine to make sure it's all correct.
Okay. Is it likely that a lot of these cables sometimes just go bad?
It's likely, especially when the cables have been bent up, tied up, gone through some wear and tear. Some cables, they just go bad. And then over time, some cables loosen also. So it could be a good cable, but it's just not plugged in all the way. Say if a monitor is out, just like the computer, the power cable you have to plug into the computer and into the outlet. So the cable may have came loose, and that's why the monitor won't turn on. I put that back in, everything works. You don't have to replace the monitor, you save money. So just small wear and tear things over time. Things get loose, things get damaged, but you can check that on the outside first before going further. I hope I explained that well.
Yes, thank you.
Mm-hmm. And then With that, we want to document everything that we see, and this allows us to track the machine's history and help make better or follow-up decisions in the future. And then we also have what is called the incident report, and that provides details of what happened and where it happened. All right, so then that was the end of chapter 2. We were very close last class. With chapter 3, we actually get to the visible computer. So a lot of this stuff, I'm going to just glance through real quick. Oh yeah, a lot of this stuff, you'll actually be able to see and identify these parts on your own machines from this class tonight. So we'll get started. All right, so here we'll describe how these computing devices work, identify the common connectors in devices, and discuss features to the operating systems. I want to break it down to the very basics. So the computer, the basic computer itself is just hardware. And we'll get to all the different parts within the computer, but it's just hardware. It is the operating system, which is the software that allows you to do things with the computer. Without that, the computer is useless. All right, so PC, that stands for personal computer, and it usually runs Microsoft Windows. Yeah. All right, so when we talk about hardware, once again, we're talking about the physical components. Keyboard, monitor, computer itself, the parts within it. And then it's the operating system that controls the hardware, well, all the different programs and calculations, and it tells, no, I have that backwards. It enables the user to tell the computer what to do. So Windows 8, Mac, well, Windows in general, Mac and Linux. And now, when we talk about the operating systems, you have what's called the UI, the user interface, and that is the software where you interact. And the graphical user interface, often called the GUI, is what gives you the images and icons to select. So example of a graphical user interface, if you look on my screen, all these icons right here on my taskbar. That's all this is. And the user interface is what we can see as well. All right, so then we have programs which we call applications. And these are what allow us to do the specialized tasks on a computer. So if we want to type a letter, we have Notepad, Microsoft Word, right? If we want to send a message, we have Outlook. Now, some of these applications, there's another term called web applications, where you do things on the internet that aren't local to your machine. Like you can download Outlook, that's a local app. But if you use the Gmail or Hotmail as your email account, that is a web-based application because it's hosted on the internet. We don't have to download Gmail, get an icon for that to access our email. We just go to gmail.com. And then some applications allow you to view information about places and people. Say Google Maps, Google in general, that's probably the best application, has a bit too much information that we would like it to have on everybody. But that is the best example right there. Okay. So now the computing process, actually, wait, before I go further, are there any questions?
Nope, great job.
All right, cool. All right, so the computing process, we have three stages. Input, so the data that the machine takes from what you put into it. Every time we type on the keyboard, the keystrokes that we put in, a click on the mouse, touch screen for phones or touch screen computers, all of those are inputs. It then takes that and processes, tells the hardware what to do, and then after processing, we get an output. So, best example, we type in some keys, that's input. What it gives us on our monitor, the letters we just typed, the sentence we just typed, that's the output. When we click on something, when whatever application or link that we clicked on opens up, that's the output from what we do and then what it gives back to us based on what we did. And the steps that just happens in between that, that's all processing. In fact, the central processing unit, the processor, CPU, that's the brain of the computer, pretty much. All right. So we then have data storage, where we can save copies of our work. Those are just hard drives. I'm not sure why I worded it like that, but that's all right. So when we save a file, we download a picture, all of that, it goes into data storage. And then our network connection is when our computer can connect to one or more computers and get out onto the web. All right, so when you understand this process, you can work with any computing device. Everything is pretty much a computer. Point of sale devices at the stores, computers at home, gaming systems, those are nothing but specialized computers. Televisions, the smart TVs, the smart watches, the phones, it's all the same thing. They all have a motherboard, processor. Everything's a computer. It just has their specialized purposes, is what I'm trying to say. All right. And then these are the steps in the computer process. So once you power it up, the processing, it starts processing the parts within to prepare for action. So if you've ever listened to when you turned on a computer, you may hear some noises, those fans, you hear the hard drive spinning, everything's getting started up for you. You then provide the input, so that's when you're taken to your login screen, or even before that. And then from there, you just have control until you power down the computer. The steps, they repeat itself. Okay, let's see. All right, so going along with you, the format is just a bit new to me. because we covered different parts earlier in the chapter. It's all right. The 901, 902 just changed a little bit with how they ordered the chapters. But basically, like I mentioned earlier, the monitor is your output device. Keyboard, mouse, input devices, and then you have the printer, which serves as the multifunction device depending upon what type of printer, and then your computer. Hold on. Okay. All right. So trying to work this. Okay. So a computer is very simple. Well, there are only certain required parts, and you can turn anything into a computer pretty much. To have a computer, what you need to have is a motherboard, a hard drive, um, RAM, random access memory, and as we go on, we'll go into more detail on what these things are. A processor, because remember the processor is the brains of the computer. It processes everything that goes through it. And then a power supply, because the computer needs power. When you have those five things, you can literally build a computer on a table, in a cigar box. Um, I've seen some people build computers on a plank of wood and then put it on their wall. It's is what makes the computer is really what's inside. It's not even the case, which we call a chassis, or any of that. That's just how they're commonly shipped. All right. So onto operating systems. When we get into the 902 exam, we cover everything from Windows Vista to 8.1. And even though we don't cover Windows 10 in the book, because the majority of us are working off of Windows 10, you're going to learn that as well. And most of us already know it, right? And it just makes it easier. We also cover a little bit of Apple, Mac OS X. Actually, that's where I mess up. Mac operating system 10 and iOS, which is for the iPhones and iPods. And then we cover Linux and Google and Android. So the purpose of the operating system is just to communicate with the hardware of the device. Gives us a user interface to be able to see with the graphical user interface. It enables the users to determine available programs, and then it gives us the choice to add, move, delete, and customize programs and data. And then operating systems also provide a method to secure systems from threats. So when we have Microsoft updates and patches, the reason Microsoft keeps sending out updates once or twice a week, usually Tuesdays and Thursdays, I want to say, is because they keep finding vulnerabilities where people can attack the operating system. So they have to patch it and then send it out to everybody. And then this is just important to know so that we understand the functions of our operating system. All right. So now we're going to get more into the system. What you see on my screen, well, when I minimize and what what you see on your screens, if you were to minimize all the tabs and you just see your background and the icons for your different applications, that's your desktop. In Windows 7 and Vista, they have what's called the arrow glass, where on your taskbar, well, this would be a bit more see-through. But if you were to hover over an application, so Windows Vista and up, it just shows you in the most minimized screen what you have on that screen if you don't want to open it all the way. So I'm hovering over Google Chrome. I can see I was last on Facebook. Okay. And so on. The Start button allows us to access our applications, different tools, and folders. And then for programs that we use a lot, we can pin them for convenience. So I'm always on Google Chrome and Firefox. I have these pinned on the taskbar, so I don't have to minimize what I'm doing to go and click on the desktop to open something. I just right-click, and I can pin it or unpin it for my convenience, just to save time and make things go faster. And then what we have down here is the taskbar that shows all of the running programs. And then the notification area, also called the system tray. In the textbook, it'll be, well, on the test and in the textbook, they'll call this area the system tray. On your bottom right-hand corner, where it shows the programs running in the background. So if I click this up arrow, applications like CCleaner, Malwarebytes, Symantec, the stuff that I don't have open, and most of the tools that we downloaded 2 classes ago, the top 5, you'll see, if not all of them, most of them, just running in the background. In your system tray, bottom right-hand corner. All right, so just a little bit of navigation. When we right-click on the mouse, it gives us a context menu for specialized options on how to deal with what we right-clicked on. So if I were to open up a Word document and say I copy and pasted something, the right-click, copy-paste, cut, other ways to interact with whatever program you're in. And then the sidebar, which applies to Windows Vista only, would have your clock and your calendar. All right. I kind of went ahead of the slides. We talked about the pinned apps. Okay. All right, so when we get into Windows 8, the biggest complaint that we had was that they took away the start button. Instead, what they gave us was a start screen where you had your desktop, and then if you clicked on the start button, it would take you to that giant screen of tiles to act as a start menu, which was a very bad attempt, but we had to work with it for about a year. And there was no start button. If we wanted to do the things that we could in Windows 10, what we had to do in Windows 8 was right-click on the start icon to get these. Where here in Windows 10, if I just click it, everything comes up. and it doesn't take me to a completely different screen, interrupting any work I could have been doing. So this was the Windows 8 start screen. Uh, desktop. And then Windows 8.1 got a bit better. It was okay. I remember saying I would never get to Windows 10, but I'm glad I'm here. And then they had this weird thing called the charms bar, which I never understood. But what it would do was if you it would come up if you placed your cursor in the top or bottom right corner of the screen. That was one of the things I disabled. And then Windows 10, where we are now. Greetings, Monica. So Windows 10 takes the traditional desktop experience that we're familiar with in Windows 7 and before, and then the Metro modern user interface of Windows 10, and it combines them. So with that, it removes the terrible charms bar, and it gives us back the start menu that we all love to have. And then another cool feature within Windows 10, and I hope you'll still be able to see my screen, let me know if you can, but it allows you to create and manage multiple desktops for grouping open applications with the task view button. So this icon right here with the three boxes, can everybody still see my screen? And all of the tabs or no?
Yes, I can.
Okay,
Yep.
good. So if I have new desktop,
Yeah.
desktop 2, that way I avoid having a cluttered screen. And if I want to go back, to switch back to desktop 1, and here's the PowerPoint and everything else I was working on. So that's a really cool feature in Windows 10. All right. And I know we have one Mac user in here. Actually, two. We have two. So if I mess up, I know I can get some help. But of course, the Mac has the regular desktop. They have what's called a dock, which has the frequently used applications as icons. And then a mission control button. Never heard of that before. But it allows you to switch between the open applications and anything else happening. And then similar to Windows 10 with the multiple desktops, they have the support spaces for multiple desktops. You see, this is why I've never heard of this before, because the mission control button is specific to Mac, and they have their own button on the keyboard, which the rest of us do not have. Okay. So, okay, wow. So with the mission control button, you have, well, in this case, it's showing 4 open apps and 9 desktops. That's, I wonder how many Windows 10 can open. And then Linux, one of my favorites. So, reason I love Linux is because it's a free operating system. You don't have to pay for a license compared to Microsoft and Mac. It's very customizable to make it do what you want to specifically. And they have what's called many flavors or distributions of Linux. So there's a Linux for everybody, pretty much. And since it's open source, which is just another word for free, and the community that hosts it, all of the software that comes with Linux. So on Windows, we have Microsoft Word or Microsoft Office, which has Word, PowerPoint, Excel. Linux has all of the Microsoft equivalents for free. On this computer, even though I run Windows, what you're currently viewing, the PowerPoint, no, um, the PowerPoint that we're all looking at, I'm not using Microsoft PowerPoint. I'm using LibreOffice because the cool thing about it is you can take the Linux applications and run them on Windows. So when I built this, I was not paying for a Microsoft license for Office. I just download the free stuff and it works. It's compatible with everything.
I'm sorry, I had a question for you. On that Linux, you think you could drop us a website, a safe one, so we can get
Oh, yeah. So Linux is very legit. In fact, I'm very happy to hear people ask for Linux. I have no idea. But many types. The main types are Ubuntu Linux, Mint, for those that like to get into or have a desire to get into cybersecurity and any sort of ethical hacking, they have a Linux just for that. And then so many desktops and phone versions, but here it is. Now, there are some software programs that we have not installed or distributed as a class yet that will allow you to run multiple different operating systems, test them out, play with them, build them and break them, and everything. But once we distribute that, you can download the ISO, and I'll show you how to install it later. Don't do anything with that tonight, but you can download it. Linux is great, and I love their mascot too, Chuck's the penguin. But we'll keep going. Next thing in the next important part of the operating system are the file structures and paths. So that's the way to demonstrate this.
Nancy, can I interrupt?
Oh yeah. What's up?
Question about Linux and the other operating system. You can use both of those on one computer, or does it have to be? Maybe I missed it. Can you run Linux on your Windows computer as well as your Microsoft computer as well as Microsoft?
There's a special way to do that. Very soon in the class, we're going to distribute the software program called VMware for virtual machines. And what you can do, in fact, I'll show you a little bit. 1 second.
that website? They're asking for money. Asking like $15.
Those are called donations, and I always contribute a donation of $0.00. Yeah.
Oh, okay, bro. Got you.
Yeah. All right. VMware Workstation, and everybody's going to get this. I don't think I haven't built anything, but I can quickly demonstrate how this works. First I have to make sure I have virtual machines. Okay. All right. So what VMware Workstation is it allows you. All right. The operating system you're currently working on is called your host system. What the virtual machine allows you to do is run another operating system within a virtual environment without affecting your actual machine. So you can browse websites, do all of that in a virtual capacity. And say you were to get a virus in that virtual machine, you delete it. Just scrap the machine without it actually damaging your laptop or computer. Sure. And I know I'm kind of speeding through this, but we'll go through this again. We'll actually be working with this a lot. So Netrunner, as you see on my screen, is another version of Linux. And you see I'm still running Windows 10 all around. But within this box, I have Linux running and installing. And as we go through the book, when we talk about installing Windows 7, Windows 8, Windows 10, this is where we're going to do it. So when you walk into these interviews and companies ask you, have you ever installed these systems, you'll be able to say, I've installed it, configured it, broke it. Well, don't say you broke it, but you know what I mean. Hold on.
I have a quick question.
I missed a few chats. Yes, I'll take your question.
So I'm kind of lost right now. So when you were on work with control, you virtually run another operating system, correct?
Right.
Okay, so what would be the purpose of running a different operating system?
So the purpose, would be just for testing, getting familiar with other systems so that when you walk into different companies or different environments, you're already familiar with it, right?
Okay.
And then say you did want to get away from Windows, which is possible. I do have friends right now that they don't have any Windows on their computers. They run Linux. But before they made the decision to jump over, they tested it virtually before putting it on their actual computer. And the way and the way it saves is that even though it's virtual, it saves like a file in your hard drive. Yeah. But then anything you save, I see the question now. Anything you save within the virtual machine is saved in the VM. And the VM as a whole is saved on your hard drive. But yeah. Because I don't have PowerPoint or any of those programs, I can't find a key, so I'll give you the link to all of LibreOffice so that you can get Word, PowerPoint, Excel, all of that, because it's backwards compatible. Anything someone sends you in Microsoft Word, you can open up in Libre, and it'll come up just the same. It's great. But just for a quick demonstration, I have a virtual machine up. I can browse the internet. It has Firefox, has its start menu, everything, just to explore. And a cool thing to do with this is as you're going through the book and it's telling you what to click on in certain operating systems, you can open this and you can click and get to those screens to better familiarize yourself with it. And don't worry, we will give you everything that you'll need. So, yeah, we just power this off. Wrong slide. Oh, that was that specific virtual machine I had running was called Netrunner Linux. All right, so back to file structures and paths, and please stop me if you have a question. I'll make sure to follow up with everyone. But we have a tree pattern. And when we talk about drives, we have what are called drive letters. So this right here is a file structure. And if you look in this left column here, the main hard drive, and it's usually the hard drive that your operating system is installed on, because you can have multiple hard drives in a computer that save data, but one of them will be where your operating system, whether it's Windows, Linux, or Mac, it sits on. And it's usually the C drive. So that's a drive letter, C. And then I have a couple flash drives in here that will take up other letters of the alphabet. So as we continue to look at this like a tree, the root directory, the root of the tree where everything starts and grows from, that's where the operating system is installed. And then when we access folders and different documents, we do so through the Windows Explorer. So this window I just had open right here, with all the folders and everything, this is called the Windows Explorer. And the File Explorer as well. And then towards the end of the last class, we touched on file extension names. And that will determine what type of file it is and tell the operating system what application to use with that file. So Word documents, letters, anything we type up and save will be a .doc or .docx. So when the operating system sees that document, it'll tell, in my case, whether to open it up in Microsoft Word or Libre Word because of that file extension. And then PowerPoint is PPT or PPTX for the newer versions. But that's what it does. And then actually, are there any questions so far about that? Just want to make sure I have everybody. All right. I'll take your question on the VM. What's up?
Can you say it out loud? Because I can't see in the chat for some reason.
The question, well, I'm waiting on the question.
Okay, now I found chat. All right, I'm good.
I used VirtualBox, and the Windows 7 I use is very small. How can I enlarge? It has been a while since I worked within VirtualBox. I'll have to come back to you on that one. That's one of my least favorite ones to use, but yeah. Usually at the top there will be like where it has the file such and such. There should be a thing for view where you should be able to enlarge the screen. Last time I seen VirtualBox, I'm not sure what the case is today, but I can check on that. Okay, so when we talk about file structures, since the C drive is the root directory, the the start of the tree, where the operating system is held, that's where our program files will be held within Windows. And then depending on the type of application, whether it's a 64-bit or 32-bit, you'll have two program files folders. In fact, everyone does. And then we have subfolders. So within Windows, if we look at this example, the C drive, main drive, within that we have a users folder. So every time you create a user on your a user account on your computer, it creates a folder for that person, and within that folder you'll see desktop, documents, downloads, pictures, music, anything that person has. And like a just like a tree or like a chart, I want to say. Every folder we make within a folder, they just become subfolders. And there's no limit as to how many subfolders you can have. All right. Linux uses the same folder structure, and then Mac has similar folders that follow that structure, but they have what's called the Finder. All right. So now, within Windows, we have the control panel where we handle the maintenance, upgrade, computer configuration, security, and then system tools, and then the command line interface. And within actually, how many people got to read chapter 3? From beginning to end, are there still some people in the middle of the chapter still need to get through the chapter? Because chapter 3, the PowerPoint, it just goes over some points, but chapter 3 goes in depth to all of these points. Okay. All right, no problem. Because what we will do on Sunday, we'll have a sandbox Saturday where we're actually going to close the book, and I'm not sure what we're going to do that day. I'm still talking with Mojo, Peter, and I. We're going to figure it out. But on Sunday, we'll go over the Chapter 3 review questions, and we'll get a bit more in depth. In fact, 1 second, I'll be right back. And I'll try and pull up a video on the tree structure that can go in a greater detail. But 1 second. All right, I'm back. Let me see if I can pull up a video on the tree structure. Um, I wonder if actually 1 second. Oh, okay, perfect example. Let me share my screen back out. So with the tree structure, you currently see folders and subfolders. This right here is this black box that I'm demonstrating is the command line interface, and it's useful when the graphical part of Windows doesn't work. So if you have no desktop, but you can get to this black box, you can still navigate through the computer and start programs, stop them, and all of that. There's always a way around something. So when I type this tree command, it shows me all of my folders that I have. We'll look into my music. So I'll actually pull this up along the folders so that we can look at it. Music, iTunes Media. All right, so if we look at my music folder, which is where this is at on my cursor, I go forward one, iTunes. So this is all the iTunes folder. And then you see these three folders right here. Automatically add, downloads, music. And within the iTunes Media folder, we have these three. And then if I go into my music folder, and you come and look at the tree, the way it's organized, you see each artist has their own folder, and under that, another branch is the album and then the song. So that's probably the simplest way I can show the tree structure when it comes to files and that. And you even got a quick glimpse into my music taste, which is great. But yeah. So we talked about the control panel, command line, administrative tools. So your Windows firewall, anything dealing with the configuration and security. All of this. In the chapter 3, did it cover some of these programs or no? Like the task scheduler?
I'm still reading, but I was scrolling through while you were doing it. Some of them I don't see.
Okay.
Yo.
Oh, all right. So one program that I guess the book kind of skips over is the task scheduler. Within that, if you can schedule certain programs to run at a certain time, That's pretty much all it does. It's sort of like automation. And then in Windows 10, it still follows the control panel. And then everything is placed under settings. In the Mac operating system, the control panel is called System Preferences. Same thing, just a different name. And then Linux, their control panel is basically called System Settings. Same thing. And then that was actually the end of the third chapter. Was there any part of this that anyone wanted me to go into more detail or clarify? Or any questions?
So, it seems like your this is Doreen. Seems like your PowerPoint's a little different from the book, but the things that you're covering, that's what's actually going to be on the exam, or should we pay more attention to the book?
Both, because the PowerPoint will cover some things that the book doesn't that are important to know.
Okay.
The book will prepare you for the test, but there are a few things in the book that it's good to know just for the test, but when it comes to real world application, that's just not how it is. Yeah. I hope that answers your question.
Can you hear me, DeMonte?
Yeah, I can hear you.
Yeah, like Mojo explained to me that what we're looking at here is your teacher's manual, correct?
Right.
Okay.
Yeah, but shouldn't it follow? I mean, but it's good. Oh, okay, never mind. I was thinking it was follow the book, but I guess it's a little different because of that.
Yeah, just a little. Yeah, just some differences. But I will say that the book will go into any greater detail, well, more greater detail than a PowerPoint presentation.
Okay, so PowerPoint is more of a summary.
Right. Just to focus in on the key points, and then if there are any questions, elaborate more on the key points.
Okay.
So we actually ended early tonight.
Okay.
I will see everybody. So the sandbox, how the sandbox works, we close the book, and we'll explore any topic in IT. And that is usually 10 a.m. Eastern Time. And it's the same password as it is to get into these classes. The password is always train. Trying to think. And then Sunday, we have the Sunday class at 4 where we will cover the Chapter 3 review questions, answer any more questions that may come up from the reading, and then we'll move into Chapter 4.
Okay.
All right. Well,
Sounds good. You and Mojo are doing a great job. Peter trained you well. As I said, I'm going to school, and it's a completely different approach. This approach to me is more efficient. Although there are a lot of people in the class, because it's not a physical classroom, I think it does give a certain level of leeway. So I really enjoy this, man. You're doing a great job. Thank you.
Thanks. I appreciate that. If I may ask,
I'm sorry. Did you say a sandbox at 10 o'clock Saturday?
Saturday morning, yes.
That's Eastern, right?
Yeah.
Okay, thanks.
And everything, even the sandboxes, they get recorded as well, so that we can look back on them. But I wanted to ask you real quick, what are you going to school for?
It's crazy. Before I even found out about this course, I had signed up for CompTIA A+ certification, 1-year course for $30,000.
Oh,
And yeah, man, I had already done it. I was in. I got my, student loan, the whole nine. And yeah, I was kind of ticked off, but I said, okay, that'll give me a double dose of the information, and I'll be doubly prepared. And I was pleasantly surprised to find the knowledge that Peter had, and the teaching style is just completely different. It's amazing. I mean, all three of you are amazing, and so I'm not upset now. I'm a little tired because I only got like 3 hours of work. I did the LMS test. I got 100 on it. So I'm getting a double dose of the information, and I'm loving it. I'm not sure. I don't think there's going to be any difference in terms of the certification that I have to get from the school than what you're presenting. The difference is you do it in 90 days. I got to go to school a whole year, and I probably won't get anywhere near the knowledge in the school that I'm going to get in this course. So I'm in like technical heaven right now.
Oh man.
90 days?
About
Yeah.
3 months.
3 months. 3 months.
Perfect world when no one gets sick or anything happens. In a perfect world, this is 3 months.
Oh, okay. I didn't realize. Okay, cool.
Mm-hmm. But yeah, well, I
Now,
hope.
we have home? We're gonna have any, I mean, we're reading what, the next 3 chapters, or what was?
Yeah, that's what I was going to ask. Are we reading chapter 4?
So we want to finish reading chapter 3, and then we want to read chapter 4.
And then meet Saturday morning at 10 a.m. Eastern.
Right.
Okay.
For the sandbox, but the next class where we'll actually discuss the chapter will be on Sunday.
Okay.
All right. Well, I hope everybody, hope everybody has a great night, and I will see y'all on Saturday.
All right, thanks. See you then. All right.
Saturday.
Peace and love, bro.